is sunny days. And anyhow, it is 13:34 hours Pacific Standard Time in Ridgecrest, California. And I just wanted to say that here's one of my things that I like to do. Smooth out my shirt a little bit. Yeah. Anyhow, I've been studying plate tectonics and volcanoes since 2001. And in 2003, I believe that Mount St. Helens blew off some steam and gas, and that really intrigued my interest in volcanism. And then I found out that volcanism is directly related with plate tectonics. Plate tectonics was actually a science that was actually recognized in the early 70s. But anyhow, it totally makes sense. So if you imagine um, a magnetic core, and that's what we have on Earth, we have a magnetic core. So with that said, in your magnetic core, imagine a ground around a magnetic core, and the ground cracks every so often. So you have magma that wants to rise to the surface, but it can't rise to the surface unless it can fill a crack. Well, anyhow, there is a constant battle between high and low pressure, high and low temperature. It's a constant battle. And what happens with the Earth is just basic hydraulics. And when the Earth cracks, the magma rises and it fills those cracks. If it cracks further, it can get further towards the surface. So the surface, especially when the surface cracks, it creates such a low pressure drop that the magma rises up suddenly. And when it does, it expands because it has a lot of gases that are dissolved in it. And as it rises through the surface, the gases expand and it pushes rock apart. And so as it rises through the surface, it's breaking rock. It's going to keep pushing rock apart. And the higher it gets towards the surface, the bigger the gas bubbles expand. And once it gets to the surface, there is no stopping it. It's coming out like you shake up a freaking Coke bottle and open up the top, it's going to spray everywhere. And that's exactly what magma does. Magma is no different except for it is extremely hot. You're talking like at 1700 Fahrenheit, you're melting steel. I worked at Newmont Gold Company before. I worked in the assay lab. I put crucibles in the furnace. I've seen what high temperatures do. And also, I see when you melt material that it it actually settles in layers, kind of like a distillery. So all the heaviest elements, which would be gold at the bottom, most likely, because I think gold is the heaviest element. Then you got lead, and then you got everything else on top of that. That just layer after layer. So anyhow, It's the same process. When I used to work at Newmont Gold Company in the assay lab, when I pulled these samples out of the furnace, um, I poured them in a mold, and anyhow, so when these materials cooled down, they all cooled down in like their little increment layers of specific gravity is what they call that. So you're gonna have a separation of material, and it's the same way as it comes out of the ground. Same setup. Like when it comes to mining, you have a a dike intrusion is what they call that. When you have magma that rises through these cracks, and then eventually the pressure drops, and then it stops and stop to the bottom of different elements of the element chart. Anyhow, I just wanted to say that I've been studying this stuff for quite a long time, and that we have some serious problems that are happening in the United States as far as like Yellowstone. I'm not really too worried about as much. I've been studying Yellowstone for quite a long time, and yes, it has ramped up since I first started studying this stuff. It is it's kind of frightening, but not kind of frightening because um the material that is in the ground right now is really not liquid enough to really like blast through the surface and cause a catastrophic eruption. Um, Although there has been a lot of magma that has a serious situation at this point to be worried about. Yes, there's a lot of activity. Last year's Steamboat geyser was a serious. Oh my God, it was serious. Steamboat geyser erupted more times last year than in um it there is a big crack at the bottom of the Yellowstone Lake. It's of concern. Um but I think that another hydrothermal explosion like what happened with Mary Bay. Mary Bay is created just a lot of steam, and the amount of melt ice stream for some reason. But anyways, so the percentage of melt with the magma underneath Yellowstone at this point is not high enough to really be concerned with. But over in California, there's a place called Long Valley. So Long Valley Caldera is what it's actually really called. More of you might recognize the name of Mammoth or Mammoth City. You probably snowboarded there or skied there before, but that whole area, there's a lot of magma underneath that area, and I went there recently. I'm only 3 hours away from there. I went there recently with my partner, and and I tried to tell her like you see this whole area. Like you see those mountains over there? And she goes, yeah. And I said, that is the edge of that side of the caldera. I go, you see this side over here? I go, that's the other edge. I go, this whole like volcanic system is for miles. I think it's like 15 miles wide and 22 miles long or something like that. And it's pretty big. Not as big as Yellowstone, but it's still pretty big, and it will cause it will cause a life altering climatic situation. Um, this whole global warming thing that they're talking about is, in my opinion, and a lot of other scientists that I talk to, it's pure political bullshit. But excuse my language. Uh, what's going to end up happening is we're going to have a global cooling that you will never you'll never even freaking believe that this is even going to happen in our lifetime. It possibly can. I'm not saying it is, but the Long Valley Cal sorry, I'm like I laugh when I'm nervous sometimes, but the- I laugh too because the news is just absolutely like docile. They are so deceiving as well, and the Long Valley caldera is more likely to cause the next ice age than Yellowstone will. Yellowstone is, they're considered overdue for an eruption, but again, Yellowstone probably won't erupt anytime soon. Probably, I mean, in a sick way, I was hoping it would happen in my lifetime because I like catastrophic events. I like the power of Mother Nature. But anyhow, I think that Long Valley will probably erupt first because Long Valley is on a time scale to where the last time they erupted whew, was about anywhere from 700 to 720,000 years ago. And it's had a lot of time to recharge. And I see from going up in that area, I see a lot of signs that that place is still very active, and there's hot springs everywhere. They've got tilt meters everywhere. That whole area, like I said, it's a caldera. So all around this area, just like Yellowstone, you have thermal features. You have fumaroles. I don't know if you guys know what fumaroles are, but what fumaroles are is they are cracks in the ground or holes in the ground, and you hear a lot of like steam coming out of them, gases. It's venting off what's underneath there. The the amount of magma that is underneath Mammoth area for the Long Valley caldera caldera area is it's pretty tremendous, and it's more liquid. It's more fluid than what's going on underneath Yellowstone, and I've been monitoring that for quite a long time. And at this point, from what I've seen over all these years, there's no significant activity, but recently there has been some significant activity uh, a little bit northeast of Bishop, California. And I don't know if you guys know this, but the North American plate is actually rotating. Well, the craton is rotating, and that is the most solid part of the United States. It's called the craton. Okay, there's cratons in other countries as well. A craton is the most solid point of any given country, any given continent, I should say. And well, the United States is actually moving and rotating, and it's moving 37 degrees southwest, and it moves about anywhere from a half inch to an inch a year. And then on the coast, you have a what they call a so here is the continent. The oceanic plate is actually a subduction zone, and it goes like this. It moves downward. It's heavy. It's very dense material. It's a lot thicker. It's a lot older. It's a lot colder. Colder means more dense. And so the oceanic plate actually dives underneath the continental plate, which is this plate. This is the United States. So you have this going on. Well, when you have that going on, look where my fingers are at. That is diving back down into the magmatic chamber or the magmatic core of the earth, and it remelts. And also, as it's grinding underneath the continental plate, there is so much friction that the surface of that oceanic plate melts. And that magma is buoyant, and it just goes back up. It tries to find the path of least resistance, which is low pressure, and tries to find its way to the surface, and it will find its way to the highest point that it can in any crack in the local generalized area as it's buoyant and it's going back up. They call that dike intrusion. So if there's a crack, you got magma that fills it. That's called dike intrusion. Anyhow, what's going on underneath Long Valley caldera has been very minimal activity. But again, it is closer to the oceanic plate. And if you look at the United States and you trace all the way down the Cascadia area, you are going to see that most of the volcanoes are anywhere from 50 to 200 miles inland off the shore from the subduction zone. And there's no way to explain it except for that's how it's supposed to be. Because you got the oceanic plate diving underneath a continental plate. It's the magma's coming up, and it's going to come up within that area. So that's the reason why that volcanoes are always around subduction zones, is because there is fresh magma and gases that rise. And you do the math, and you go all the way down from Washington to California, and you're going to see that these volcanoes line up, and they're anywhere from 50 to 200 miles away from each other, and they're anywhere from 50 to 200 miles away from the shore, from the subduction zone. It's freaking common sense that happens. So, anyways, we've had a lot of movement, and then we've had some areas that have not moved. The subduction zone keeps moving. The continental plate, the United States, keeps moving. The continental plate of the United States is actually being shoved southwestwardly because on the East Coast, in the ocean, in the Atlantic Ocean, there is what is called a mid-Atlantic ridge. And the mid-Atlantic ridge is magma that is coming up from the earth, and it rises to the surface, and then it pushes the plates apart. It pushes everything to the east and pushes everything to the west. And then if the west, if it pushes it to the west, if there's any resistance, that plate is going to follow the path of least resistance. And that's the reason why that the United States is moving 37 degrees south-southwest. But anyhow, we have some major issues that are going to happen. I'm not going to say it's happening tomorrow. I'm not going to say it's going to happen next week, but it is happening. And there's a little basic knowledge about how plate tectonics are Earth's magnetic core and how volcanoes um, operate. The only reason why they're there is because they are places where the ground has broken enough to where the Earth's magnetic core can come to the surface. And once they're there, it doesn't mean that they're always going to be there. But once they're there, they're like a pimple on your skin, and that's the weak spot. And the oil or the magma is always going to want to come up in that area because that is the path of least resistance. It's basic hydraulics. That's just how our Earth works. We have a magnetic core. We have pressure. Pressure always moves to low. High pressure always moves to low pressure, and it can't get there unless it has a path of least resistance. It's just like electricity. That's just the way it works. So anyhow, um, sunny days. There's a little bit of a lesson, and I will bring you more. We'll talk to you later.